Hi everyone, welcome back. I had people asking me, said the same in the previous video, if I just make some simple, straightforward, here's how you find the sides of a right angle triangle. So here we go. Looking at this right angle triangle here, this side, if you look at it, even if you do it, I do it like that and do it very rough, that side is shorter than that side. Remember, this is the longer side, and the longer side is opposite that little right angle, and the longer side, of course, is called the hypotenuse. So this one here is actually shorter than that one. I'm not going to write that as the hypotenuse. That one there is what we call the hypotenuse. Let's have a look at the formula. Now I write the formula as h squared equals a squared plus b squared. A lot of people write it as c squared. When they say c squared, they're meaning the hypotenuse is the c. I prefer the h. Let's have a look what the numbers are. If that's the hypotenuse, I can't put it over here. A lot of people think there's the x and they keep thinking, oh, that's got to go there. No, it doesn't. The hypotenuse is 4, so that's a 4 squared. And then you can pick whichever one you like. But I talk about we're creatures of habit. When we talk about creatures of habit, we usually do things the same way. So for example, if I fold my arms, I automatically fold that way. To go the other way is awkward. If I fold my legs, if I put my shoes and socks on, I actually normally put on my left shoe and my left sock before I put on the right. Sometimes I think to myself, that's silly, and I do something different and go the other way around. But we're creatures of habit. So what I always talk about in my classes is this is actually the important one. We're actually trying to calculate that length without having to draw a diagram. So you imagine trying to draw a diagram of that and make it reasonable. You'd have to figure out angles and all that sort of stuff. Instead, this will give you the answer, which is absolutely fantastic. So the important one is that x. I'm going to call that one there first as an x squared. Remember, they've all got squares on them. Now, not deep and meaningful understanding, we're just doing the numbers. So this one will be a 3 squared. Now, a lot of people then get stuck into I don't know what to do. Let's have a look at it. 4 times 4 is 16. Most of you be okay with that. You can pick up your calculator if you need to, or take your time and calculate it. Now we've got x squared. Now we've got a 3 times 3 is just 9. And we've got a problem. Trying to figure out what that number is when we've got these numbers here and numbers here. Now a lot of people struggle with their equation solving, but I'm going to teach it this way just for the moment. Let's see how most people go with this. Later on I'll show you shortcuts and other ways of thinking. So if I want to get rid of a plus 9, I want this written by itself so it tells us the answer to the question. And a lot of people don't understand that about equations. I want that written by itself so that tells us the answer to the question, which is that length there. So if I wanted to get rid of plus 9, I talk about the opposites to both sides. I actually often write opposites to both sides. So what's the opposite of adding 9? It's subtracting 9. If I subtract it from this side, I subtract it from that side. If you want to go watch my equations videos called 2-step equations, just type in Robert Prestwidge on YouTube and then put next to it 2-step equations and up they'll come. So what we're left now, 9 take 9 is 0, and no one bothers to write x squared plus 0. They could if they wanted to, but the plus 0 is just there like that, and I actually say over and over again that 9 take 9 is just gone. And the nice part is now it tells us that 16 take 9 is 7. Now a lot of people need to see it the other way around, so I'm going to swap it around to that way. You don't have to if you're confident. How do we get rid of a squared? Take a square root. That's the opposites to both sides. How do I get rid of a squared? I get a square root. And that square root will give us the length of that side. So I could actually say that this side is root 7 meters and leave it at that. Or you can put in your calculator and find out what that is. So I've got the answer to that written over here. So if you pick up your calculator, find the square root button, press the 7, and then press equals or execute, whichever way your calculator operates. And you get this number like this, which is 2.645. And I can put a fair few numbers on, say those numbers up to there. And what we're looking at is, if you want very accurate, you use more decimals. Most of the time, a lot of people only look at 1. In the last video, I used 1 decimal place accuracy. On this one, I'm going to use 2. So if your teacher said 2 decimal place accuracy, back to the peekaboo method, 2.64, it might actually be closer to 2.65. How can you tell? You look at just the next digit. Don't go right over here, just the next digit. It's a 5. If you see a 5, you round up. That number is 2.65 metres. Old school, we used to write 2dp for 2 decimal places. Next one, a little bit faster. H squared equals a squared plus b squared. And you go, well, am I getting the shorter side? Well, it probably doesn't matter. As long as you know that x is not the hypotenuse, the 6 is the hypotenuse. So you've got 6 squared, and then creature of habit, I put that one first. Otherwise it looks a bit different and it mucks students up. 6 sixes are 36, and you've got an x squared, and 5 fives are 25. And then you've got to figure out what to do. We want this by itself, so it tells us the answer. This by itself. So what's the opposite of plus 25? Take 25. If I take 25 from that side, I take 25. And that's all about balancing up the scales. If I had a set of scales or a seesaw, balancing it up. 25 take 25 is gone. And I'm left with this, and I'm going to automatically write that over here just as a habit. And 36 take 25 is 11. Now I need the number times itself that equals 11, and that number is actually the square root of 11. And I've got it written here, 3.31662. And then if I want 2 decimal places, a lot of you will just look at it now and go, is it closer to 0.31 or is it closer to 0.32? Big number is closer to 0.32. So if you want accuracy and you're actually measuring things, more decimals makes it more accurate. This is one with the special numbers. So h squared equals a squared plus b squared. That one's a hypotenuse. If you're still having trouble, across from there is the longer side, and we call the longer side the hypotenuse. So that's a 10 squared. And then x next, doesn't have to be, but I do. And then the 6 squared. Then we can look at it and you can go, 10 tens are 100. 6 sixes are 36. Again, the same as I keep saying all the time. Need to get rid of the 36, so the question tells us the answer. If I do it to one side, I do it to the other side. Now this side turns out to be 64, and this side turns out to be just x squared, because that's gone. I'm going to keep writing it. 36 take 36 is gone. By gone I mean 0. Then you're looking at what number times itself will give us 64, so I could have written that straight away that way. And the number times itself that gives us 64 is 8. So this one turns out like the other one in the previous video. I had a 3, a 4 and a 5. So if you have a quick look at it, previous one we had a 3, a 4 and a 5. Turned out to be exact numbers. If I double the 3, if I double the 3 I get a 6. If I double the 4 I get an 8. And I double the 5 I get a 10. So 6, 8 and 10. So if that was in centimetres, I could draw up a little right angle triangle, go 6 centimetres that way, go 8 centimetres that way, measure across and you get 10. And that's what I normally do for an intro video, which I'll do another day.